Okay, here we are, number 14 here from the homework for vectors. We have triangle ABC, and we want to find, with these various points, we want to find the size of the angle between these two vectors. Well, in order to do that, I need to find vectors AB and AC. To get AB, I subtract B, subtract A, and AC is C, subtract A. And if I do AB and AC, I get those values quite quickly here by that computation. Now, when I want to find the size of the angle, I know from my formula look that there's a formula that says cosine theta equals u dot v over the magnitude of u times the magnitude of v. That's in the formula booklet. Well, here are my vectors I'm going to use. I'm going to go u dot v will be ab dot ac over the magnitude of AB times the magnitude of AC. So doing the dot product on these two, 0 times 1 is 0. 0. 1 times minus 3 is minus 3. 2 times a minus 2 is a minus 4. Over the magnitude of these, which is 0 squared plus 1 squared plus 2 squared over 1 squared plus a negative 3 squared plus a negative 2 squared, which gives me negative 7 over square root of 5, and the square root of 9, 10, 14. All right, so now I know cosine of theta equals that. I plug it into my calculator. I go second, I'm going to put myself in degrees, make sure I'm in degrees so I can, if it doesn't specify, you can be in either degrees or radians. So if I go second cosine, it's negative 7 divided by all square root of 5 times the square root of 14. And I get an angle of 146.8 degrees. So to three significant figures, theta is 148 degrees. 47 degrees. 47 degrees. Okay. Now, hence or otherwise find the area of the triangle. Well, if I want to find the area of the triangle, I also know from my formula booklet the area is equal to half AB sine C. Well, if here is A, B, C, I know my angle A here is 147 degrees. And I know that AB has a length of root 5. And AC has a length of 147. I can take these values and plug them in. So half square root 5 times square root 14 sine of 147. This formula works with C being in between A and B. Be careful with your calculator. I want the final answer to be good to three significant figures, so I'm going to use this angle not rounded. So it's 0.5 times square root of 5 times the square root of 14 sine of, I'm going to pull this angle down. I want all the significant figures. And I get 2.29 is the area of this triangle. 2.29. There's no units given, so I'm not going to worry about my units squared. All right, so then line L1, let L1 be parallel to AB, passing through this point D, and AC is, line 2 is parallel to AC, passing through this point there. All right, so let me move up here, and I'll see if I can remember some of these values. So let's get line 1. Line 1, I know it's going to be going through the point 2, 1, 0, my starting point, plus some parameter times the vector AB, which is 0, 1, 2. 0, 1, 2. Line 2 is going to go through negative 1, 1, negative 1, 1, 1, plus, I'm going to call it P, a different parameter, through AC, which is 1, negative 3, negative 2. 1, negative 3, negative 2. All right, so those are my two equations of line. Second part says, hence, show that they do not intersect. Well, the first thing I'm going to look at is the direction vectors here. This direction vector and this direction vector. They are not what we call scalar multiples. I can't take this value, multiply by a common number to get this. So therefore, they're not parallel. So then my options are that they intersect at one point, or they are skew, meaning there's no intersection. The question's asking me if there's skew. To do that, I'm going to try to see if there's an intersection, which means I'm going to make these equations. I'm going to make this equation 2 plus 0t equal to negative 1 plus p. This is the x value. The x is going to equal the x. The y is going to equal the y. Minus 3p. And the z, 2t, equals the z, 1 minus 2p. I have two equations with two unknowns. I need to solve for those. So I'm going to rewrite them. I have, well, actually this one I can find p fairly easily. I know that goes away. So p equals 3. If p equals 3 from here, I get negative 1 plus t equals 1 minus 3 times 3 is 9. So minus 1 plus t equals negative 8. T is equal to add 1, and I get negative 7. So here's my p and my t using x and y. If the lines are skew, and I take my values for p and t and plug them in here, it should not be equal. It should be different values. So if I plug p in and t is 2 minus 7, which is 14 with a negative. This one will be 1 minus 2 times 3, which is negative 5. Those two are not equal. Therefore, they are skew, non-intersecting.